Hello everyone, my name is Radu and I'm a PhD student working under the supervision of Professor Ravinder Dahiya as part of the Bendable Electronics and Sensing Technologies group at the University of Glasgow. This poster presents a novel design of a wearable human-machine interfacing device used to control a sensorized prosthetic hand while offering the user real-time vibrotactile feedback. Effectively, this device allows the operator to feel what the robotic hand is feeling, while enabling a direct control interface to the prosthetic. This device employs a biaxially flexible and stretchable 3D printed structure based on the serpentine curve. All communication is done wirelessly using the Bluetooth Classic protocol, which is fast enough to ensure a consistent real-time response. We ran several experiments to test the performance of the device. Firstly, we tested the stretchability of the serpentine mesh structure. The structure had a maximum displacement of 14.1 millimeters by finite element analysis and 15 millimeters experimentally. Secondly, the latency of the wireless data transfer was 130 milliseconds with approximately 100 milliseconds for the vibration information transfer. This ensures the device has a reaction time which can go undetected by a typical operator. A typical operator has a reaction time of around 140 milliseconds. So 100 milliseconds can go undetected and can appear as a real-time stimulus. Lastly, the device functionality was tested. The prosthetic hand managed to successfully mimic the user's gestures. In conclusion, this device shows great potential for a plethora of applications, ranging from nuclear waste management to robot-assisted medical recovery. This brings us to the end of the presentation. Thank you for taking an interest in this poster. I am looking forward to answering any questions you might have.